Okay, we are going to continue with the steady state electromechanical power. So, steady state electromechanical power. PEM. Okay, so and we are going to do this for our squirrel cage. Uh, In the last videos, we figured out that these were our voltage equations for our squirrel cage, and this was our equivalent circuit. Now, we're gonna, apart from how we found the electromechanical power in our other model. So we have omega r L naught, and then the imaginary part of is times is conjugated, ir conjugated, isr conjugated, I'm sorry. So this was for what we figured out for our vector state model. So we are gonna change these currents into our steady state currents, and we figured out that they were, in the last video, we figured out that they were, for is, it was 3/2 is e to the j omega st. Ir was 3/2 ir e j to the omega s minus omega rt. And now if we want isr, we need to multiply this times e to the j omega rt. We saw this also in the last video, to move from one reference frame to another. So we got isr equals to 3/2 ir ej omega st. Here in the equation we have isr conjugated, so our isr conjugated will be our 3/2 of ir conjugated, and we change also the sign of this angle, omega st. Okay, so now we can plug this in our equation. So we have this equation here, and what changes is our current. So we know that our is this, and this multiplied by this. Okay, let me make this smaller so we can see it, the page. Okay, so here we have plus omega st minus omega st, so this will go to 1. This can go with this, and this can go with this. So we have PEM equals to, I'm just gonna move this out, half or not, and the imaginary part of the multiplication of is times ir conjugated. Okay, so now if we go back here, if we take this equation and we just look for is, we're gonna see that is equals to r2 over s times ir minus r2 over s times ir minus j omega s L2 ir, all this over j omega s L naught. So here we have this equation for is. Maybe we can factor out the IR, so we're gonna have minus R2S plus J omega S over 2 times IR over J omega S L naught. And if we go back to our equation of power, we move our is. It's now this, and this is multiplying our IR conjugated. Now we know that when we multiply two vectors and the same vector but one of them conjugated, we get the magnitude. So we get the magnitude squared. So this or not, we'll go with this. When you divide minus 1 over j, you get j. I'm gonna put this here. So we're gonna have imaginary part of j r2 over s plus j omega s L2 times the magnitude of IR square. Okay, so remember we only care about the imaginary part. When we multiply this, we get imaginary, but when we multiply this two, we are gonna get, this is j, and minus 1. So this will have no imaginary part. So finally we have our PEM equals to 3 halves. R S R2 over S times the magnitude square of IR. Okay. Now if we try to put these two with this square, so we have 3 R2 over S, and if we have here a square, we have IR. So if we put this inside here, we have to do it in square root, and this is IR in RMS. So we have PEM equals to 3 IR in RMS square multiplying R2 over S. Okay, and now we know that S is our speed in mechanical minus our speed in electrical over our speed in mechanical. So this is equals to omega S over omega S minus omega R over omega R equals to 1 minus omega R over omega S. So omega R over omega S is equals to 1 over S. So I'm sorry, and I was forgetting that here we have our omega R. Yes, from here I stop writing. Here we have our omega R, omega R, omega R, omega R, and we have omega R over omega S. So omega R over omega S is 1 minus S, is omega r over omega s. So if we take this equation, we are gonna get here 3 times 1 over s. And this is gonna give us 3 r2 over s ir squared in rms minus 3 r2 I r squared in rms. So if we look at our circuit, here we have R inductor, big inductance. Here we have another inductor. Now this resistor that we had here was R2 over S. So we are gonna call this part over here that had the R2 over S, we are gonna call PAG for air gap power. And if we want the developed torque, we have to divide the PNG over the mechanical speed, and we will get 3 IR squared in RMS times R2 over S times 1 minus S over, I'm sorry, this is over R in electrical, over R, and this is gonna give us TD equals to our air gap power, that is all of this part of here, multiplying 1 minus omega s, that this is our slip, omega r minus over omega s, all this over omega r. So we will get TD equals to the air gap power. Over here I'm gonna do it, so air gap power equals to omega r over omega s over omega r, and this is the same that having omega r over omega s times omega r. And so we say there is our air gap power over our omega s. So our synchronous and mechanical. So we can say that our power is 3 I squared r in RMS multiplying R2 over S over our synchronous, omega synchronous in mechanical. So these are our equations for power and for developed torque.